Hello subscribers! Today I'm going to show you how to solve the top K most frequent elements algorithm. I'm going to jump right into it right now. Before I do though, if you find these videos helpful, please pound on that like. It really helps the channel. Today I'm going to show you how to solve the top K numbers algorithm. So in this example, you can see I have a very big list of numbers, and I'm going to try to find the top 3 numbers from this list. So in doing this, the most efficient way to solve this is to first create a dictionary. So what is that going to look like? It's going to look like something like this. You can see 1, we have 1, 2, 3 ones. 2, we have 3 twos. 4, we've got 1, 2, 3, 4, 5 fours. 5s, we have 1 5. 6, we have 1 6, and then 7, 1 2 3 4 5 6 7 sevens. The next step in this problem, from this dictionary, the next operation we'll do to return the top 3 is we'll create a heap from this. So we're going to use a min heap. So in doing this, we're going to sort the min heap by the number of occurrences of the number. So it's going to look something like the least, of course, is going to be 5, and then 5 or 6, and then we'll put 1, 2, and 7. I think that's what the min heap is going to look like. So if we have to do a comparison of this min heap, you can see 5 is, of course, 5 and 6 are tied for 1 for the least. The next would be 1 and 2, and then 7. So that's properly sorted. And then finally, from the min heap, we'll build an array. So we'll pop off the last 3 elements of this array. So you can see that in sorted order, the answer would be 7, 2, and 6. So another way of representing a min heap would be to use, instead of as a tree data structure, you could simply use this list. So where it would be arranged like 5, 6, 1, 2, and then 7. And then to grab the last 3, we would simply find the last 3 from the list. So I'll show you this. It's kind of complicated, but in code it's much clearer. But this is the broad concept. So it's a 3-step problem. 1, create the dictionary. 2, you use the heap, and then 3, you'll pop off the answer. And that's it. Let me dive into some code. And by the way, if you find these videos helpful, pound on that like, and then leave a comment. It really helps the YouTube channel. Alright, let me adjust my screen. I'll show you my implementation of this algorithm. So you can see this is a similar list. I think there's more 7s, but basically what we just went over in the video. We're going to return the top 3, and basically in this implementation, I leverage Go's container heap. You can see that's imported. I've imported format, and in doing so, when you initialize a heap, it requires the implementation of a few convenience functions. So what I call heap here is this is our container. So remember, we have this idea of we're dividing this up first into a dictionary. So dictionary tracks the value mapped to a frequency, so a count of the numbers. Excuse me. This dictionary will be outputted into this element, and the element will be pushed into the heap. So I call this type heap, which is a slice of elements. We have to implement length. So length is simply length of the heap, length of the slice of elements. We implement less, which is a comparison between the ints I and j. This is simply we're comparing the frequency of both. And then to swap, we're simply swapping location in a slice. And remember, H here is the heap. Heap is a slice of elements, and this is we're just swapping indices. In addition to this, we implement push and pop. Push and pop, they act on interfaces because remember, I've implemented this custom element. All implementations will be different, so therefore it takes an interface. So we have to first dereference the pointer. We append the dereference pointer to pushing in x, and then we have to specify what exactly x is because it's an interface. So in this case, the interface is an element, so hence the parentheses of element. Pop, again, we're popping off an interface. The variable x interface is simply x is what we're returning, and then we have to first get the x. So we take the collection of the slice of the heap, and then we'll get the last. We take the length of it. -1 is the last location, so we're getting the last element of this heap. And then we take the heap and then we modify it to pop it off. So then we save every element up until the last index of the heap. So you can see that is what this colon means in this case. So then those are all of our convenience functions to actually use the container heap. That's all done now. So this is this logic here, the top frequent numbers. It takes a list of numbers, and then k is the amount of top numbers that we're checking for. And then first step, remember, we're building this hash map. So we've got a map of int to ints. We initialize our collection of elements, our slice of elements that we call heap. And then we initialize our answer, which is a slice of ints conforming to the signature of the function of size k. And then what we do is we'll range over the numbers passed to top frequent function, and then we will just, for each occurrence of the number, we will simply increment upwards. So for example, we'd create what we went over in the video, that counting the ones or the twos or the fives, so on and so forth. Then we fill the heap. To fill the heap, we first initialize the heap with the slice of elements, and then we will range over the hash map, pushing each of the elements into the min heap, and then we'll pop it off if the length of the min heap is greater than k, which is the amount of answers we want. Then what we do here, we will range over. This is this final step down here. We're ranging over to build the output array. So we're ranging over the min heap, appending the element's value to the response. So this is going to be in backwards order. So then we simply reverse the slice. So you can read through this on your own. Basically, we loop backwards, then we calculate the forwards indices, and then we rebuild the slice going in both directions, and then we return the result. So looks like I made a change to that. I don't want to change it. We will run it. Go run main. And you can see we returned 7 and 4. Oh, the change I made was 3. So Vim, I'll do that change again. We'll output 3 answers instead of 2. Go run main 7, 4, and 1. So in our example, it looks like it's a little bit different because I think this program filled in, I have to research this, but basically in this case, the number of 1s is the same as the number of 2s. They're both 3. So I think it just depends on the order in which it's a tie. So for all intents and purposes, it's the same. So really 7, 4, 1, and 3. So anyways, that's it. I hope you found this video helpful. If you did, again, please pound on that like. It really helps the channel. Leave some comments on things that, if you have any questions, feedback, if you could think of a better implementation of this code. Thank you very much for subscribing. Goodbye.